Hello, and the purpose of this video is I can derive the quadratic formula. In this video, we will go through the quadratic formula derivation. We will start with a general quadratic equation and try to complete the square. It will lead us to the quadratic formula. Let's get started. So, for step 1, we start with a quadratic equation, just a general quadratic equation in the form of ax squared plus bx plus c equals 0. If we were trying to complete the square, we would first want to make sure the coefficient in front of x squared is 1. So right now we are going to assume that a, what's in front of x squared, coefficient a, is not 1. So let's divide everything by a. So step 2, we would have ax squared plus bx plus c equals 0, and all of that would be divided by a. So over on the right-hand side, we'll write our reasoning would be to divide equation by a. Okay, then on step 3 here, we have x squared plus b over ax, because we don't know what a is, but we'll call it a for right now, plus c over a equals 0. 0 divided by anything is 0. So now when we're at this step, what would we want to do to complete the square? Well, we would want a perfect square trinomial on the left-hand side. And b over a divided by 2 squared does not equal c over a. So let's move c over a to the other side, and we'll replace it with what should get a perfect square trinomial on the left-hand side. So our reasoning will be move c divided by a to other side. Again, we are trying to complete the square. Okay, so step 4 now, let's figure out what should be in place of that c over a. So half of b over a would be b over 2a, right? If we take b over a and times it by 1/2, we get b over 2a, and then we square it. So let's go ahead and write x squared plus b over ax plus b divided by 2a squared equals negative c over a, because we move that to the other side, plus b divided by 2a squared. So our reasoning for this would be we added b over 2a squared to both sides of the equation. Okay. Step 5. We now can go ahead and square b divided by 2a all squared. So we get x squared plus b over ax plus b squared all over 4a squared equals negative c over a plus b squared over 4a squared. So all we did was square b over 2a, so we simplified that a little bit. Okay, step 6 now is let's go ahead and get a common denominator on the right-hand side of negative c over a plus b squared over 4a squared. Let's get that a common denominator so we have one fraction. So the common denominator of a and 4a squared would be 4a squared. So I have x squared plus b over ax plus b squared over 4a squared equals, now if I multiply that first fraction by 4a, I have to multiply it by the top and the bottom. So negative c times 4a is negative 4ac all over 4a squared, and then plus b squared all over 4a squared. So I just got a common denominator of 4a squared on the right side of the equation. Okay, so let's continue on. Step 7. Let's convert the left side let's factor the left-hand side because that's a perfect square trinomial. So let's factor that and rewrite it, and then we'll also simplify the right side with that common denominator of 4a squared. So step 7, if I if I factor x squared plus b over ax plus b squared over 4a squared, I'm going to get x plus, then the square root of b squared over 4a squared is b over 2a. So I just factored the left-hand side, and if I simplify the right-hand side over there, I have a common denominator, so I can write my numerator as just one term. So I'll write b squared minus 4ac because I know that's actually part of the quadratic formula. So instead of writing negative 4ac plus b squared, I'm going to flip-flop that because I know I probably will at some point. All over 4a squared. And so what I just did there was I factored the left-hand side and simplified the right. So factor left side, simplified the right. All right, let's continue on. We are almost done. In step 8, if I have something being squared, how do I undo that something being squared? Well, I simply take the square root of it. So I'll take the square root of both sides. So my reasoning would be square root both sides. And what I get on the left-hand side is I just get x plus b over 2a equals, then on the right-hand side, plus or minus, now I can't take the square root of my numerator, right? b squared minus 4ac, because I cannot take the square root of variables that don't have, variables that don't have even exponents, right? That won't come out nicely. Right now I'll still have something left under the square root, so I'm going to leave the whole numerator under the square root, the whole expression of b squared minus 4ac. But the square root of 4a squared, square root of 4 is 2, and the square root of a squared is a. So I have square root of b squared minus 4ac over 2a. Now that's starting to sound pretty familiar, right? Sounds like the quadratic formula. So I'll say took square root of both sides. And then now for the next step, we're on step 10, I'll simply move the b over 2a to the other side. So x equals negative b over 2a, so if I subtract it, I get a negative on the right-hand side, plus or minus the square root of b squared minus 4ac all over 2a. So I solved for x. Now I'm almost done, but I can simplify this a little bit further. Since I have a common denominator of 2a on the right-hand side, I can write this term, the whole right-hand side as one term, right, with one denominator. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I simplified, and I'm done. That's the quadratic formula. So again, the quadratic formula is derived from a general or generic quadratic equation. When we try to complete the square, we end up getting the quadratic formula, and that's where it comes from, and it can work to solve any quadratic equation. Thanks for listening to the derivation of the quadratic formula. Have a great day. Bye-bye.